Hi, this video is about balancing chemical equations. Any course you take in chemistry or any textbook you use in chemistry is going to fairly early on get to balancing chemical equations. It's like the thing. It's the big thing in chemistry, isn't it? One of the central things. I'm queuing these videos to Brown, LeMay, Bursten, and Murphy's Chemistry, the Central Science, 11th edition. But any chemistry book you use is going to, at some point, get to balancing chemical equations. This particular chapter in the book I'm using is on stoichiometry. Stoichiometry is the study of substances consumed and produced in chemical reactions. So you set something on fire, there's a chemical reaction. You take a liquid, you pour something else in it, it starts to bubble and it gets recombobulated. That's a chemical reaction. Chemistry is stoichiometry is the study of those kinds of chemical reactions in chemistry. It comes from a Greek word. Some 2,400 years ago, the Greek word was stoichia, which basically means elements. Back then they didn't have a periodic table with 100 plus elements on it. It was basically 4: earth, air, fire, and water. But that's not important right now. So let's talk about the before and after of a reaction and get some terms out there. First of all, let's make it clear, something you should know by the time you're watching this video in a course, that matter can neither be created nor destroyed, that is, most of the time. For chemistry's purposes, in physics we can do some really crazy stuff. But for the vast majority of reactions, the reactions that any of us are going to experience, we're not dealing with radioactivity, most of us. But in the vast majority of chemical reactions that we're going to experience, matter is going to be conserved, and you're going to have the same atoms on the front end and on the back end, and you're going to have them in the same amount. So the same number of oxygen atoms on the front end, you're going to have that same number of oxygen atoms after the reaction as well, and so forth and so forth and so forth. So that's the key principle that helps you to balance an equation, because you know that the number of atoms you have of something on the front end is going to be the same number of atoms you have on the back end. So we call the stuff before the reaction the reactants. The atoms and molecules before the reaction that are going to have a experience of one another, they're the reactants. After the reaction, we call those the products. So before, reactants. After, products. So there you have that. Now, while we're getting some terms out there, let's use some highfalutin terms. Subscripts and coefficients. What are these things? Don't let the highfalutin language scare you away. So let's say that we have 2 water molecules. Most people know that H2O is water. Any molecule of water has 2 hydrogens and 1 oxygen. Well, in this 2H2O, the 2 in front is called the coefficient. It tells you how many water molecules you have. So in 2H2O, you have 2 water molecules. So the number on the front is the coefficient. It tells you the amount. Now the mini 2, the smaller 2, is a subscript. It tells you that in the heart of hearts of water, that any water molecule, any individual water molecule is going to have 2 hydrogens bound to 1 oxygen. So the subscript 2 is part of the identity of the water. So don't confuse the 2 on the front with the 2 that's a subscript. The 2 that's a subscript is part of the molecule. The 2 in the front, and it could be some other number, is just telling you the amount, the one on the front. It's like the difference between a toupee and real hair. The 2 on the front, it comes off. It's a toupee. But the 2 on the bottom, that doesn't come off. It's going to hurt if you try to pull those 2 hydrogens apart. Okay? So, in other words, the coefficient tells you the amount of molecules or elements, and the subscript has to do with what molecule you're dealing with in the first place. Okay, that's all preface. Now we get to what this video was allegedly about in the first place, which is balancing equations. So this is an unbalanced equation. Why is it an unbalanced equation? It's an unbalanced equation because I have more oxygens at the beginning in the reactants than I have oxygens at the end in the products. It doesn't add up. I have 3 oxygens, 2 on the oxygen, gaseous oxygen tends to be diatomic with 2 oxygens. So the 2 oxygens in the oxygen gas and the 1 oxygen in nitric oxide, that's 3 oxygens. And yet in nitrogen dioxide at the end of the equation, I only have 2 oxygens. So, this is an unbalanced equation. So, what am I going to do? Well, the nitrogens work. I've got 1 nitrogen on the front, 1 nitrogen on the end. My problem is with the oxygen. Somehow I need to get the odd number of oxygens on the front into an even number that matches the even number at the end. How am I going to do this? Well, I think the easiest way is for me just to say 2 NO, 2 nitric oxides on the front, and then see what I have to change, to work that out. So I put a 2 in front of here, and then now I've got 4 oxygens in the front. So if I put a 2 in front of this, does it work out? Let's see. So I have 2 nitrogens here, and I have 2 nitrogens there. Check. Nitrogens are good to go. I have 2 oxygens here, and I have 2 oxygens here. 2 plus 2 is 4. Do I have 4 oxygens here? Yes, I do. 2 times 2 is 4. So, ding! I've got a balanced equation. I have 4 oxygens on the front, and 4 oxygens on the end. I have 2 nitrogens on the front. I have 2 nitrogens on the end. There is peace in the force. Everything's good. Okay? So, here's some other information in this section. Sometimes you'll put in parentheses after the molecule what form it's in. So you might say, O2 with a G in parentheses so that you know that it's oxygen gas. L in parentheses would stand for liquid. S in parentheses would stand for solid. Sometimes you have AQ in parentheses, which stands for aqueous. That means it's dissolved in water. It's in a solution. Sometimes a delta, that's the Greek letter D, or delta. A delta over the arrow in a reaction means that there's heat being added as part of the reaction. So here's an example of a balanced equation that has that added information. So CH4, which is methane gas, and G, it's a gas, plus 2 oxygen, which is gas, diatomic molecules like oxygen there and hydrogen tend to be gases, yields a carbon dioxide in gas form. Now here's the surprise, plus water in a gas form. So this reaction, when it takes place, yields water vapor or steam, as it were. It doesn't yield liquid water, it yields water in a gas form. Who knew? But it's balanced because here's 1C, there's 1C, here's 4 H's, 2 times 2 is 4, there's 4 H's. Here's 4 oxygens, 2 times 2 is 4, and do I have 4 oxygens here? 2 plus 2, yep, bingo! I have a balanced equation. Let me do one more example of balancing an equation. This is an unbalanced equation. How do I know? Because I have like 3 oxygens here and only 2 here. So if I take iron, Fe is the symbol for iron, if I take iron in a solid form and I have it react with gaseous oxygen in its diatomic, meaning 2 atom form, it will yield ferric oxide is the way we say this. But how do I get it to be balanced? Well, let me start with the iron since it seems to be the less problematic one. So I've got 2 irons here. Let me add 2 irons to the fire there on the front. So there I've got 2 irons, and my irons are balanced, but my oxygens still aren't. How am I going to do that? Well, I think my intuition is to turn an odd into an even. If I put a 2 in front here, it's going to mess up my irons, but 2 times 3 is 6. I'll have 6 oxygens, and then if I put a 3 in front of here, I'll have 6 over here. Let's try that. So now, like I said, my irons are imbalanced because I have 4 irons and 2 irons here. I can deal with that. Hold on. But let's see if the oxygens pan out. So on the reactant side, I have 6. 3 times 2 is 6 oxygens. And 2 times 3 is 6. I have 6 oxygens on the back side, on the product side. Bingo! Okay, so I have my oxygens taken care of. Now I only need to take care of my iron. How do I do it? Well, there's 2 times 2 is 4. What if I up this one to 4? There is peace in the world. Because now I have 4 irons on this side, and I have 4 irons on this side. I have 6 oxygens on this side, and I have 6 oxygens on this side. I am at rest. The video may now come to an end.